I would start now with the Python basics. Maybe I would like everybody to try to follow this. So we will execute some Jupyter notebooks together now. As usual, we are going to start by activating our environment. So I opened my command line here, and then I'm going to do Mamba activate Napari Latam, which is the environment that we have prepared for this course. Now, you can see here that I'm in this path, but I have stored my repository elsewhere. So I will go there and call Jupyter Lab from there. So I already know where it is. So I'm using this CD command to go into the documents. Actually, this is something that Peter showed a bit on Windows. So on Mac, this made different a bit. So I think it's ls instead of dir. So dir shows you all the files that are in this directory. And then I want to go to documents. So I do CD documents, and you can see that the path here now is changed. And I also want to go into GitHub because my repository is in a folder called GitHub. And then I'm going to go to the Napari. I press the tab because if the folder is there, it can autocomplete. And then I'm going to enter into this. So now my current path is this one here. And I said in the chat to somebody, you can also type, I think let's see if this works on Windows. No, this probably works on Mac. So you can know the current where you are with this command here, probably on Mac. But otherwise the path is here. You can also paste the full path already, just going step by step. Now I'm going to type Jupyter Lab. So in your computers, you could also like navigate to where you have the folder with the contents of the workshop by CD and then putting the full path to that. I think somebody also showed this here. So if I go to GitHub, then Napari shop. Yes. So if I hold Shift and right click, hold Shift and right click, there is this copy as path. So, but you have to hold Shift. In Mac, you should hold, I think it was Command, not entirely sure. If I do CD and then paste it here, this should also work. Like I was already there, but yes. And then Jupyter Lab. These documents and GitHub are very particular for my computer because I have stored the course in these folders. Most of you, if you just download it with zip, it should be under the downloads folder. So you could go like CD, and then, for example, to make it easier, let me go to downloads, and then I can right click and copy as path. Then I come back here and I paste it. So you see now I am under my username and then downloads. And then here maybe you would have the Napari Latin America workshop. It depends. So that will change from computer to computer. In my case, it is in this place here. So I hope that answers your question. So it really depends where you start the repository in your computer. If I open Jupyter Lab from here, so I am in this place now. It's like I double clicked it here and went to this folder, but I'm doing this via the command line. So by the command line, you use these CD commands here. If I open it from here, we just test the difference now. Let's see. So this is opening a new tab here. Yes. And then you can see in here on the left that I am like my first folder already basically has the repository content. You can see the YAML file here. The data is in this data folder. The notebooks are inside this doc folder. And then I can navigate inside or go back. Now I will shut down. Okay, so this tab doesn't do anything anymore. I'm gonna close it. And now I'm just going back some folders. So now I am under C users and my username, and I'm gonna call Jupyter Lab from here. So Jupyter Lab will work either way. I was just saying that if you already go to your repository, then you are already, you don't have the whole folder structure here on the left, because then you have to do the navigation here. You can choose actually. So you see here, like on the left, I have this, now I have other stuff because I started from a different place. Then in my computer, I have this folder called documents. And then in my computer, I have a folder called GitHub. And then inside here, I have many other folders. One of them is this Napari Latam workshop. And now I'm finally here. So you see now I have to navigate inside here. That's the only difference. So I hope everybody can get to Jupyter Lab and then navigate to where you start your the repository for the course. And then we should be like in the same window. And then we're going to go under docs. So double clicking docs. And now I'm double clicking like day 1. And now I will double click this other folder, this Python introduction. And then you'll see already some notebooks here. And then you should open our first Jupyter notebook. So if I double click it here, then a new tab opens. And then this is basically the content that you see when you open the Jupyter book, like the HTML version of this. But now we can execute the cells here. So here's the explanation. If I hit Shift Enter, I basically executed this first cell. You see that it is selected because it's this blue bar. So if you click, you're selecting a different cell. This first cell is a markdown cell. So if you double click, then you actually see what was written there. So this cell is of type markdown. You can see here on top, it's written markdown. This means that this cell does not execute Python code. It just executes this text formatting. And then there's this markdown syntax. Then you can read more online, but you can specify this is going to be a title because I put this one hashtag here and etc. If I execute this cell, so I can click on the play button, then it's displayed like this. The second cell, on the other hand, is Python code, and then you can see here that's code. You can actually change to code from code to markdown whenever you like. And then if we execute it, so now I just hit Shift Enter on my keyboard. You can see here on the left, there is this little number 1. It means this was the first code executed in this notebook. And then it just printed hello world, which was written here. And here's basically explaining that you can create new cells by, well, you can always try these buttons here. So this plus button inserts a new cell below every time I click it. There are some keyboard shortcuts that you can see here, like if this cell is selected, then I press A. This one, it would be better actually. So this is selected, I press A, it inserts a cell above, and B would insert the cell below. You can delete it. I don't know if everybody would have these icons, but you can delete the cell by clicking on this trash icon. If you don't have it, you can also select the cell clicking here and hitting the letter D twice. So this deletes the cell. So, and then basically the small exercise here is like, add a new Python code cell below and use the print command to print your name. So I leave the exercise to you. If you already know Python, this should be straightforward, but yeah. Then I'm gonna start the second notebook here, which is called Don't Try This at Home. We're gonna do it together here. So that's what I mentioned before with the order of execution. So if you look at this notebook, you see here that A has value 5. Imagine you got this notebook from somebody. So A has value 5 and B has value 5. Then we see here that A receives A plus 1. So this means that A was 5 plus 1. So now A has a new value, which should be 6, right? And then we type A plus B. So it should be 6 plus 5. So we should get 11, but we get 13. And then, yeah, I see that's weird. That's basically because whoever executed this probably executed some of these cells out of order or even more times. So now if we execute this like 1, 2, 3, then we actually get 11. So that was what I mentioned by maybe coming here to kernel and then restart kernel and run all cells before you stop working with this notebook, so you know that it's working properly. Because I could come here and then execute this cell again, or maybe I could execute this cell multiple times. So each time I execute it, I'm actually incrementing an extra 1 value to this variable A. And then this result would be like different. If I do it again, it will be different again. So yes, I mean, while you're testing things out, this happens. But then always try to always remember to come here and then do restart kernel and run all cells. Then it asks you if you want to do it. Then you say restart. Then it will like execute all of them. And then I mean, this notebook is working nice. There's no error. There are no errors. And then all the values are there. And then you can, for example, save the current state. I think that was one of the questions as well. Yes. Let's see. So this one, there's no exercise, was just to show you this thing that you can do. Yeah, and this one would be what I just showed by assigning integers or strings. So in this case, I'm giving this number to variable A, and we can determine what type of this variable has by running this type and then putting the variable inside it. So it tells me that this variable is an integer. If B is a floating, then it should give float. And then I can sum them up and have a float result. With strings, it's the same thing I showed, like maybe I will let's see if I'll just go with you in this one, and I'll leave probably 5 to 10 minutes to do the exercises because they should be very fast to do before going into lists. So I'll leave this as an exercise. Basically, it's concatenating strings, and I will jump to the next presentation because I think I want to go to the other content before I hand over to Melissa. So I hope everybody can execute these notebooks. We'll just be continuing in this order here. But I have a second PowerPoint which I'd like to share. I'm going to talk about Python data structures. So besides having individual variables, Python can also store arrays, or what we call in Python lists of variables. So lists are variables where you can store multiple values. You'll see soon why we can relate those to images. So we can create a list, for example. If you put any number in these square brackets, this is already a list in Python with one element, 0. If you do this multiplication by 5, it's going to expand this list 5 times. And then it's just telling, give me 0 5 times. You can also change these values. So now you can say the value. So this list is stored in this variable array. And then you can also say the number, the value, the first value in this array, so the array position 0 should get value 1, and then you have 1. And by the way, Python starts the indexing with 0 and not with 1. So the first position in Python is 0. You can give like at the position 2, the value 5, and then you can also mix types inside lists. So you can also give a string to another position, and Python is fine with that. So here is how you could modify an entry in a list. So this is a list of numbers, and then for the first position, I give the number 5. Yes, that's how I said the element 0. Yes, and this is how you could potentially like start a list of a certain size, like let's say 10 zeros. So lists, if you have like two lists, one like this and the other like this, if you use the plus sign, means you are appending the second list to the first one. So if you do ones plus twos, these are two lists, you get a new list called numbers, and this actually it's a longer list, so it contains both lists. You can also like have a long list and get a subset of this list by telling, okay, I just want numbers at the position 2, starting at position 2 and ending before position 4. So if you see here, this is position 0, that just happen to have the same numbers. Then position 1, position 2, so we get this guy. Position 3, we get this guy. And when we hit position 4, we do not get position 4, we stop before it. So we get a new list, which is actually smaller, containing only those two. There's a third parameter that you can use in the syntax, which is the step. So you can also like tell it, so I want to get like the position 1 up to position 8, but please go in steps of 2. So it will jump one position. Yes, so it's typically 1 if you do not provide this third argument, but you can also give it like this. So this is like the syntax. It's like the starting position, the stopping position, so it will stop before this guy, and the step. So let's see some examples. We have here like a list, and the content is like, now it's a list of strings, and here are the indexes. So if you want to get the first element, you can just type data position 0, get the letter A. If you put position 1, you get letter B. And if you want to get both of them, we can do something like start from 0 and go up to 2. So it will get these two, but yes, it will stop before including then the second position. Yes, we can go, if we want to include it, we put 3. If you do it like this, like from position 1 to position 2, so it will just get this B here because it starts at it and stops before 2. And it's also sometimes interesting to know the length of your list. So you can use this Python function len and then provide the list, and this list contains 9 elements. Yes. Also, if you omit some of these starting or ending, Python will just assume that you're starting from the beginning or going up to the end of the list. So here you have just a column, and then you have 2. So it's implicit that should start at 0. So it would get like just A and B. Also here it's the same thing. On the other hand, if you omit the end of the list, it will just go up to the end. It's starting at position 2 and go get me all the elements up to the end of this list. Also here with 3. With the step, as I said, we can like get all the elements in this list, but go in steps of 2. So it will always skip one of them. As I said, we can omit like this explicit definition of the initial and ending values. It will then it looks like this. It will like assume it starts from the beginning, assume it goes up to the very end, but in steps of 2. So these two syntaxes are equivalent. You may also want maybe to get the odd numbers or the odd letters here. So we could also define that you start at the position 1, but still jump in steps of 2, and then you would get the other letters. In Python, you can also go backwards. So you can also understand the index here as going from 0 to 9, but also from right to left as going from negative value. So -1, -1, -1, -2, -3. And then if you say, please start at position -2 and go up to the end, it will go up to the end and say -1, -2, and then from here up to the end. And then you get just the 2 final letters. Sometimes this is useful just once you get the last element or the last 2 elements, then you can do something like this. Yes, if you invert this, like please go from the very beginning up to the before last element. So yes, it will go up to the -2 index. So it will just leave out the 2 last elements of this list. And yes, you can also use negative indexes to do in between. Sometimes if that's not possible, like we'd like to start in -5. So we could, it always goes from left to right. Like they start, the left is the start and the right is the end. So this works because it starts from -7 and goes up to -5. But if you try to go from this direction, like from -5 to -7, just -5 is in this case bigger. So it just, there's nothing there. So it returns an empty list. And one very interesting and useful fact about this is that you can also put a negative step, and then it means that it will go, it will basically reverse the elements. So the step is still 1, but because of the minus, it means it will basically go backwards. So you can easily reverse a list by applying this colon -1. Yes, it can be fancy and put -2 to jump one element if you like. You can modify elements in a list. So imagine you have a list of measurements, and then you want to modify measurement number 1. You can do it like this. If you want to add a new element or a new measurement to this list, you can use this .append method from the lists, and then you have like the both results. So you change the value number 1, and you also appended the new value by the end of the list. In Python, so I showed you lists. You also have a very similar but different type of variable called tuples. So tuples are also like this sequence of different numbers, but they are immutable. So it means that if you try to do what you just did here, like assign a new value to this variable, you should get an error. This sometimes is useful when you have variables that are not variables, you don't want them to change. They are properties of something. So you can basically, instead of creating a list with the square brackets, you create a tuple with the parentheses or round brackets, and then they are not easily changeable. So you get an error if you try to change it. Of course, this is Python, so there are ways that you can turn this into a list and really change it. But this is a good hint that these values are not meant to be changed. So just a sneak preview here about an interesting library, which is pandas. So I'm not going to go into detail, just showing you the potential of this. So if you have like tables, because there I was showing like a list of measurements, this library is already installed in this environment. You can easily see these measurements like shown as a data frame. So they will be displayed in Jupyter Notebook like with a visualization like this. Some other very important packages that we'll be using for handling data and especially images. So Numpy is the one library that we'll be using to basically to store images and manipulate them. So you can, like, this already installed in the environment. I'm just showing you the web page here. And the difference is that I can give you a quick example. So in lists, let's say here I have a nested list. So I start with a list, and then inside this list, I have 3 lists, right? So this is like a matrix, like a 2D list. If I try to, for example, what would be intuitive, like let's say I want to multiply all these elements by 2, but because these are lists, it's going to replicate them twice, as I showed you before. So in case if you really want to like manipulate your array like element-wise, Numpy is the way to go. So you can import Numpy like this, for example. Here we're just giving a small alias to it. So we don't need to type Numpy all the time. We can just type NP. And now I basically get this nested list or multidimensional list, and then I give it here. And now, I know it looks the same, but now it's a Numpy array. And then if we do this with a Numpy array, you get probably what you would expect, like you're doubling all the elements in this array. And then we can also use Numpy to do some basic statistics. So imagine you have like this, this can still be a list, but Numpy has some functions like Numpy mean, and then you basically can get the mean of some of these measurements. And then, of course, you can look at the documentation to see there are many parameters that you can also set. Or you can also do the question mark for each of these functions on the Jupyter Notebook to get like a brief description there of what it does. So when doing image processing, one of the main libraries is scikit-image. This would be very probably better shown Wednesday. But so that you know, you can install it also with Conda. You already have it installed in this environment. And then it's the library to do image processing. And matplotlib would be like the library to like the standard Python library for plotting. We can also send images to Napari, and that's better because it's more interactive and they can also see better n dimension. But maybe to show some 2D images, it's also good to know how to use matplotlib. So this is an example of how you could plot an image. If you have like this image stored in a variable, you can use matplotlib to just display it in the Jupyter Notebook like this. All right, so how do we open images? You can just, for example, one of the ways that you can open TIFF images, we basically can this is scikit-image. So we can do from the scikit-image so schemeg.io. So this is a module for input and output, import the emRead function. And then here you should give the path to your image. And then once you do that, you will start the result in this variable called image. And this image, if you just hit it in a Jupyter Notebook and execute it, what you get is like, yes, a Numpy array. So here you have like, it looks like a multidimensional list, but this is actually a Numpy array. So you can actually see that these are many lists. So we can think of them as lists or arrays, as rows. And yes, so it's like an image, like an array of arrays. So in this case, a 2D image. And you can see that you have 2 square brackets. So that means you have at least a 2D array. Yeah, so visualize images, you can use matplotlib. Also, scikit-image has one convenient function to do that, which is this emshow. There are examples in the Jupyter Notebooks. And this is a grayscale image. You can also change the color map. So it's just changing the way that you visualize these intensities with colors. So that just means that we can visualize the same image with different colors. Sometimes this is nice to show some aspect, like sometimes people like to see this sort of in a heat map situation, but this does not modify the image, does not turn it into a colored image. It's just for visualization. So just represented these values, which are the same with different colors. And so what I was showing about like getting elements from lists becomes now useful for images. So as images are like 2D lists or 2D arrays or multidimensional arrays, you can index and crop Numpy arrays just like you would it works like Python arrays. So if you have like an image like this, we can specify some indices here that we actually want from line 0, from row 0 up to row 138. So on the rows, on the first dimension here, we want to get 138 rows. But now we have just the only difference, you have like a second dimension, which we can also specify here the same way. So for the second one, we would like to start at the column 128 and go up to the end of the array because there's nothing specified here. By doing that, we're basically taking this piece, this right upper corner of this image and cropping it out. So this is very useful because some images are just bigger, but they just have zeros around that you actually don't need. You just save memory by cropping your region of interest that you're working on. And you can easily do that by just providing some indices to this Numpy array or image. And you can also apply those tricks that I showed you, like if you want to use the step to jump elements. When you do that to images, basically you are like sampling your image. So in this case, you get the full image, but you just get every 5th pixel or every 5th row and every 5th column. And then this image looks pixelated, so it's much smaller. You can see here the axes are smaller because you are basically skipping some rows and columns. And if you want to invert an image, flip an image, you can also use the trick of putting the -1 there. So in this case, we are just inverting it vertically. We're just horizontally, sorry. We're just inverting the columns of this image. So whatever was on the right now is on the left. And again, if your program throws errors, don't be afraid. Actually, take a look. And also there's this saying, like, there are 2 ways to write error-free programs, and only the third one works. So we will get errors. We already got errors, but the errors are telling you that, yes, something, they're pointing you to what's going wrong, and then maybe how we can fix it. So in this case, like, you can typically see maybe even if this message is very long, sometimes you can see like where this error is happening and sometimes some information of why it is happening. Yeah, so read what appears. Yeah. So the take-home message here is like that lists can be accessed like this. So this is very important. This also works for images. And that strings are just list of characters. So you can also understand strings as being like a list of individual characters. Tuples are immutable lists. And columns in tables, they're also lists. So you can also always think like that. And images are multidimensional lists, or simply they are just NumPy arrays. So if you learn how to handle getting the indices, and this is the key to deal. You have to learn how to handle lists in Python. I think so I'm done with the presentations. I may have been running out of time. I wish I could go with some Jupyter notebooks. Maybe I just show one for today. There are at least a couple notebooks here that I'd say you can try running it tomorrow, because you have this gap. If you have the time, do it to do some of these exercises. So all these notebooks, they have explanations. So try to read them and then check, understand what is, like, you can study them. And then by the end, usually there is like a small exercise so that you can really try. It's like a small challenge for you to do. I'll go just show briefly a few of them. So this one is about lists and tuples. So there's number 5 here. And then it is explaining like in more detail about the things that I just showed in the presentation. Yes, so list tuples, and then there's a small exercise by the end. There is this one about indexing. So that's the situation where you provide some indices to access specific elements of a list, for example. So you may relate to my presentation just by seeing this notebook. Here I'm also like giving hints how to slice these lists. Yes, and also like how to use the step to jump some of them. And then again, there is a small exercise that you should try to get these 3 specific numbers in a single line. This 5B is actually very important. So if you have to choose that you don't have time, please choose this one because this is the one which explain better what images actually are. So you can always understand images in Python as being these NumPy arrays. That's the most basic concept I want to keep here. So I'm showing you here how we can create like a 1D NumPy array. So this is like a list. You put np.array, and then this is like a NumPy array now. And as I showed in the PowerPoint, the behavior is different. And this is like a 2D NumPy array. And you can visualize this array that you just created with these numbers as an image with matplotlib, for example. And then each of the values represent an intensity. And then you can also load more complex images. They are just NumPy arrays, just bigger. Also, colored images. In this case, it's an RGB image. So you also see that. I didn't say that in the presentation, of course, because I didn't have the time to put it there. But a colored image is just an image with multiple channels. So RGB, and then you can see here the shape of this cat image is like 300 rows by 451 columns, and this 3 means there are 3 channels, the red, blue, and green, and they together display the cat like this. There's this exercise to split these channels individually, so you just have to use the indexing over this last dimension here. And finally, there is one notebook that was not properly uploaded, so I will try to send it tomorrow morning. But in any case, this one, because it's the one, I think this one you may not have, because there was a problem when I was uploading it. I'll try to upload it tomorrow in case you don't have it, and I'm sorry for that. But this is the one basically showing you how you do the cropping. So you can load like a full image, and then if you provide some indices here, you get some pieces of it. And then you can subsample, you can flip it, and the exercise is actually to crop one or a different image in memory that is in the data folder. I think that's where I stop.